Welcome to CSEGuru. In this session, we will discuss the topic Deque operations. In that, we are going to discuss insert left. Already, we have discussed the basic concepts of Deque data structure and what are the two variants, that is input restricted Deque and output restricted Deque. Both we have discussed, and what are all the basic operations we can able to perform in Deque data structure. There are four operations: insert right, insert left, delete right, delete left. Now in this session, we will discuss insert left. Okay. So if you want to understand the basic concepts of Deque data structure, I'll provide the link in the description for your reference of the old session videos. Okay. So now this is the algorithm to implement insert left operation. So here step 1 is, if left is equal to 0 and right is equal to max minus 1. If both the condition is true, in the sense, in that case, the Deque data structure is completely full. Whatever the memory locations you have allocated, all the memory locations you have placed the element. So it has to write overflow state and it has to go to step 4 exit. You cannot able to perform new insertion. For example, here if you are considering this as the Deque data structure and the size of the Deque data structure is totally 8 memory locations. Starting memory location is 0 and last one is 7. Max minus 1 memory location is 7. And now the left pointer is pointing to 0th memory location and the right pointer is pointing to max minus 1 memory location. So in this case, what happens? We have allocated totally 8 memory locations. All the memory locations we have placed the element. Left is pointing to 0, right is pointing to max minus 1. So here, if both this condition is true, in the sense here and operator, both the condition is true, in the sense it will write overflow state and it will exit. New insertion is not possible here. That is the meaning. And there is one more condition to check for Deque data structure is full or not. That is left is equal to right plus 1. For example, consider the Deque data structure with 8 memory locations. Okay. Starting from 0 to n minus 1. That is max minus 1, that is 7th memory location. Now here, if you are considering, the elements are there here. Okay. So this is the right pointer position and this is the left pointer position. So when this condition will be true, in the sense, suppose if I am implementing insert left, what do we have to do? Decrement left pointer by 1 and then perform the insertion. Now left pointer will point here, perform the insertion. Some 90 I am inserting. Okay. So when the left pointer reaches 0th memory location, you need to reassume this left pointer to max minus 1 position. If there is a free space towards the max position, max minus 1 position, in the sense, you need to reset left pointer from 0th memory location to max minus 1 memory location, because from here further we cannot able to perform insert left. Okay, it has reached the maximum position towards left. That is, the 0 is the maximum position towards left. Okay, so you need to reassume the left pointer to max minus 1 position and place the element, some element you place it. Now, if you want to insert left, again, decrement left pointer by 1 and place the element. Now, left pointer will be pointing to 6th memory location. And what is the right pointer position? It is 5. So, left is equal to 6. Right is equal to 5 now. Okay. So what is this condition? Left is equal to right plus 1. 5 plus 1 if you are implementing, that is 6. This condition is true. And check here the Deque data structure. Whatever the memory locations we have allocated, all the memory locations we have placed the element. Okay. So there are two conditions to check the Deque data structure is full or not. One is left is 0, right is max minus 1, both the condition. Another one is left is equal to right plus 1. In this case also, if this condition is true also, you have to write overflow state and go to step 4 and exit. New insertion is not possible because Deque data structure is completely full. Whatever the memory locations you have allocated, all the memory locations we have placed the element. That is the meaning. Okay. Otherwise, if this condition is false, go to step 2. If left is equal to minus 1. What is the condition for Q data structure empty? That is, front is equal to minus 1. Front and rear both is minus 1 or front is minus 1 in the sense. In that case, the data structure, Q data structure is empty. So here instead of front pointer, we will use left pointer. If left is minus 1 in the sense the DQ data structure is empty, you need to set the left and right pointer to 0th memory location. 0th memory location you need to set and place the element. So whatever the element you want to insert now, that is the first element you are going to place it in the DQ data structure. That is the meaning. Previously data structure is empty. This is the condition for DQ is empty. Okay, suppose if this condition is also false in the sense, go to else part, and here if left is equal to 0. So what is the condition here? Consider the DQ data structure like this. Totally 8 memory locations, 0 to max minus 1. Now see, right pointer is pointing here. Okay, and left pointer, this is 100. Okay, left pointer is pointing to 0th memory location. Suppose in this case, if you want to perform insert operation in the sense, when left pointer is pointing to 0th memory location, further if you want to perform insert operation by decrementing the left pointer by 1 in the sense, there is no memory location here. Okay, so in this case what we have to do, reset left pointer to max minus 1 memory location and then place the element. Okay, when left pointer has reaches to 0th position, reset the left pointer to max minus 1 position and place the element. Suppose if this condition is also false, this is the normal case, left is equal to left minus 1. That is, this is the DQ data structure, and here left is pointing to 2nd memory location and right is pointing to 5th memory location, for example. Okay, so in this case what we have to do, just decrement the left pointer by 1. Now left pointer will point to 1st memory location and place the element. Whatever the element you want to place it, place the element. That's it. Okay, so these are all the cases for insert left. If left is equal to 0, right equal to max minus 1, DQ data structure is full, or left is equal to right plus 1, DQ data structure is full. In this case, you cannot able to perform insert operation, just print overflow condition and exit. Next, if left is equal to minus 1, DQ is empty, what is the element you are going to insert? That is the first element you are going to insert. So set the left and right pointer to 0th memory location and place the element. This condition is false, go to else part, and here you have to check if left is equal to 0 in the sense, set left pointer to max minus 1 position and place the element. If it has reached 0th position, set to max minus 1 and then place the element if empty space is there towards max minus 1 position. Suppose if this condition is also false in the sense, left is not reached to 0th position, that is the meaning. Left is not minus 1, left is not 0. In that case, just decrement left pointer by 1 and place the element. Okay. In step 3, if you are considering, this is to place the element. If this condition is true in the sense, it will go to step 3 and place the element. Set the left and right pointer to 0th position and step 3, place the element. These two conditions it won't execute, else part it won't execute. Suppose if this condition is false in the sense, it will go to else part, and here if left is equal to 0, if this condition is true, it will set left pointer to max minus 1 position and then it will go to step 3, place the element. And if this condition is also false, it will set the left pointer to left minus 1 position and then it will place the element. Go to step 3 and place the element. So these are all the conditions for insert left operation in DQ data structure. Thank you for watching this video.